Okay, these are notes on matter and density, and you could take them over 2 days if you want to break them up. I'll tell you where a good stopping place will be. So we've already looked at a lot of questions about matter in class, and then density is a property of matter. So anything that has matter has this thing called density. A property is like a characteristic. It's how you describe something. So what is matter? So we have this nice picture here of the sky and some clouds and the ocean and a cliff. There's some sunlight on the cliff. So think about which parts of this picture are you seeing examples of matter, and then is there anything in the picture that is not matter? Okay, so let's get some definitions. So matter is anything that is made of particles, and we call those particles atoms. So some of you have heard this word before, atoms, some of you have not. Some of you know what an atom is, some of you do not, but matter is made up of little particles, and we call those particles atoms. So now you understand, or you've at least heard that word. Anything that is not matter is energy. So we can take everything in the entire universe and we can say that's either matter, it's made of atoms, or that's energy, it's not made of atoms. So like if you think of a candle, the candle is matter, it's made of atoms, and even the little wick is matter, it's made of atoms, and I'll give you some hints about how you can know that. But the flame, that's actually energy, it's not made of atoms. So here's how you can know if something's matter other than your teacher just telling you. All matter has mass, meaning we can measure it on a scale, right? And that's based on its atoms. The more atoms it has, the more mass it has. So if you think about the scale, if you can measure it on a scale, then it's got to have mass, okay? Also, all matter has volume. It takes up space in the world, or in the universe. So if it has mass and it has volume, it's got to be made of atoms, because those atoms take up space, and because they're particles. And so if it has mass and it has volume, it's matter. If it's not matter, it's energy. So looking at this diagram, or at this picture, most of the things in the picture are matter, and matter can be categorized or put into 3 different categories. One is solids. Anything that's solid is matter. Okay, so like the whole mountain and whatever grass or trees is on it, that's going to be matter. Also liquids. So all this water in this ocean here, that's going to be matter. So if it's solid or a liquid, then it's definitely matter. That's another way of knowing this. And the third one is gas. So the air is actually a gas, and those are atoms, and those atoms have mass, and those atoms take up space. And we're going to see that in a couple of weeks. So the 3 ways you can tell if something's matter is that it has mass, so we can measure that on a scale. It has volume, so we can see that it's taking up space. And it's a solid, a liquid, or a gas. So if all those things are true, then it's got to be made of atoms, and it's got to be matter. If those are not true, then it's energy. So in this picture, the sunlight, for example, is energy, okay? We don't know if it's well, it wouldn't be a solid or a liquid. It I guess could be a gas, right? But it doesn't have mass. There's no mass in light. And it doesn't have volume. It doesn't take up space. Okay, so like if you think about when you turn on a light in the room, it doesn't like push the air out of the way or anything like that. So it's not taking up any space. This is a really good place to stop if you want to stop for the night. If you want to go on, keep listening. So then what is density? Density is how much mass something has for its volume. So it's a combination of mass and volume. So if you think about a water bottle, right? A water bottle is going to have the same volume no matter what is in the water bottle. But if it's empty, it's going to have a different mass than if it's full. And because it has a different mass with the same volume, it's got to have a different density. So density you can actually calculate. It's a number, and it's mass divided by volume equals density. And a really good way to remember that I've heard a lot of people say is they say density breaks my heart. So I want to show you why density would break your heart. So if I draw a heart here, there's my heart, and then I break it in half like this, the top half of the heart kind of looks like an M, and that M is for mass. The bottom half kind of looks like a V, and that V is for volume. And then if you remember your math class, like if you have a line going through, like if you had 6 over 3, you'd know that that is 6 divided by 3. And so this line means the divided by. So that's how you can remember that it's mass divided by volume. Okay, so let's look a little more closely at density. And you have on your note-taking guide this chart. And so we have some choices. We could have high mass, so lots of particles, and a large volume. We could have a high mass and a small volume. We could have a low mass and a large volume, so few particles but taking up a lot of space. Or we could have a low mass and a small volume. So what I want you to do is just pause the video for a minute and think about how you could draw each of those cases. The high mass, so lots of particles in a large space, lots of particles in a small space, few particles in a large space, and few particles in a small space. So pause the video, think about how you might draw those. Alright, so the way I drew them was, here's my high mass, so lots of particles. And you know, your definition of lots of particles may be different than mine. I think there's 10 particles in here. Yep, so my particles are dots, and then here's my volume. So that's lots of particles in a large volume. So then my high mass and a small volume, it's the same 10 particles. I was really careful to have the same number of particles, but I made my square a lot smaller. For my low mass and a large volume, I was really careful to make the volume the same size, but now I only have 5 particles instead of 10. And then for my low mass, small volume, again, I have the same 5 particles as I have here, but the same volume as I have here. So now in a minute, I'm going to ask you to pause the video again, and I want you to write a number 1 for like the most dense in the box you think is going to be the densest, and a 4 in the one that is the least dense. So you can go ahead and you can pause the video now. So you should hopefully have written this, that this one is the most dense. It's got the most number of particles for its volume. And this one is number 4, it's the least dense. It's got the fewest particles for its volume. You can see these particles are really spread out. One of the things that we're going to talk about later is what's between the particles. Okay, so like we've got a particle here and a particle here. What's in this area in between? So start maybe thinking about that. What's between the particles? Now, this one here, so the high mass large volume, and this one here, the low mass small volume, it's hard to tell which one is more dense, and they might be equally dense. If this one, the particles are packed just as tightly as this one, it's really hard to say. This one maybe does look a little denser than this one, but it could be that they have the same density. You could make it so that they do have the exact same density. But at any rate, they are definitely in the middle between the most and the least dense. So please write down any questions you have on your note-taking guide, and we'll review these notes in class. Have a good night.